We are starting chapter 3, polynomial and rational functions. So the first function that we will be reviewing over, because you've learned this in Algebra 2 already. So we are reviewing over quadratic functions. So we need to be able to graph them on paper without the calculator, find minimum and maximum values, and find intercepts, and all the different characteristics. So on slide 3, we have the vertex form. So a reminder that H and K are your vertex. So HK is your vertex. So that'll be where the point or where the parabola turns, changes direction. It is symmetric on the axis of symmetry. The parabola is symmetric with respect to the line x equals h. That's called our axis of symmetry. And then to know if the parabola opens upward or downward, you look at the a value. If the a value is negative, then it will open downward. If a value is positive, it opens upward. Okay, so we are going to go through all of these steps with an example. So you'll first determine, does it open upward or downward? Find your vertex. Find the intercepts. So for the x-intercept, you'll have a number for x and a 0 for y. And you could have one x-intercept, two x-intercepts, or no x-intercepts. Y-intercept, you will have one of those. It's where you have a 0 for x and a number for y. And you'll use all of this information to help you graph it in the shape of a parabola. So let's look at our first example. F of x equals negative, parentheses, x minus 1 squared plus 4. So how does the parabola open? This negative tells us it opens downward. And the vertex is our h and k, so hk. So the standard form says x minus h squared plus k. So because the formula has a minus in there, the h is just 1, and the k is 4. So that is the turning point for our quadratic function. Find the x-intercepts by solving f of x equals 0. So we are going to use the function and set it equal to 0. So negative x minus 1 squared plus 4 equals 0. So this goes back to one of those very first sections that we learned about, how to solve equations. So we're going to move this forward to the other side. So we have negative parentheses x minus 1 squared equals negative 4. Then to get rid of the negative, we can divide by a negative 1, which just really changes those to positives. And so we have x minus 1 squared equals 4. Square root it on both sides. Squared and square root cancel, leaving us with x minus 1 equals plus minus 2. So we're actually going to have two intercepts here, two x-intercepts. So we'll say x minus 1 equals 2, and x minus 1 equals negative 2.
Why would you not distribute?
So plus 1, so we get x equals 3, and then add 1 to this side. We get x equals negative 1. So our two x-intercepts are 3, 0, and negative 1, 0. So let's go on to the y-intercept. So to find the y-intercept, you're looking at what is the x value that makes, or x equals 0. What is the y value when x is 0? So it says f of 0. So that means I'm going to substitute in 0 into my equation. It's negative parentheses, negative 1 squared plus 4. You can put this in the calculator. I'm just doing it by hand. Negative 1 squared is 1. Still have that negative out front, plus 4. Negative 1 plus 4 is 3. So my y-intercept is when x is 0, y is 3. Mm-hmm. Okay, so now we will graph it by using the information that we found. So the vertex will be what we graph first, that 1, 4. So over 1, up 4, that's our vertex. And then we have the x-intercepts, 3, 0, and negative 1, 0. And remember that axis of symmetry is right down the vertex. And then one other point that we can graph is our y-intercept at 0, 3. So remember the axis of symmetry shows us that it's symmetrical on both sides. So if I have a point on one side, the one that is directly across, I can also graph that one because it's symmetrical. So then we make our parabola. And let's also talk about domain and range. So domain is how far left, how far right. So if we look, it's going to go negative infinity to positive infinity. And then our range is how far up, how far down. So the lowest it goes is negative infinity, and it goes all the way up to 4. So we'll write this as negative infinity to 4. And it includes 4. So we put the bracket there.
If I got questions, no.
Okay, so let's move on. Okay, so if it's not in the standard form, if it's in the general form, ax squared plus bx plus c, then we're going to have to use something a little different, right? Oh, that was vertex form. This is standard form. So we are going to have to use our quadratic formula. And when we use our quadratic formula, we can use that negative b over 2a. And so we are going to use that to find our vertex. So you'll find a negative b over 2a. And then you'll plug in whatever you got for negative b over 2a for the x value. It's like substituting in that x value. Your x coordinate, negative b over 2a. Y coordinate is found by substitution. And then the same thing with knowing whether it opens upward or downward. You look at that a value. If it's negative, it opens downward. And then if it's positive, it opens upward. Our vertex is already listed there, negative b over 2a. And then you plug it in. Intercepts, to find our x-intercept, we're solving for the x-intercept. So we are most likely going to use our quadratic formula. Unless you can factor it and solve it that way. And then we will also find the y-intercept by plugging in an x value in for 0 in for x value. Whenever you do that, all you're left with is that c value. So this is your y-intercept. And then we'll plot them, connect points. So let's look at this example. So it says negative x squared plus 4x plus 1. So how's it going to open? Downward. And then to find the vertex, we're going to use that negative b over 2a. So what is the b value? 4. So negative 4 over 2 times a negative 1. So we have negative 4 over negative 2, which just gives us a 2. So now we need to find the y value. So we substitute in the x value. So this was the x value of the vertex. So now the y value is found by doing substitution. So we're going to do negative parentheses 2 squared plus 4 times 2 plus 1. Okay, so we have negative 2 squared is 4, plus 4 times 2 is 8, plus 1. 4 plus 1 equals 5. So that's the y value of our vertex. So we can write vertex is 2, 5. To find your x and y intercept, x-intercept is found by solving. So in order to solve this, we need to do the quadratic formula. Yeah, I sing it too. So we have A, B, and C. So go ahead and do the substitution. See how you do. So this would be 16, and then negative, negative, so plus 4. That becomes 20 inside there. So x equals negative 4 plus or minus square root of 20 over negative 2. And we know it's not going to be a whole number because that square root of 20 doesn't reduce to a constant. It's like 2 square roots of 5. So I'm not going to worry about doing that. So, well, I guess we could. It'd be negative 4 plus or minus 2 square roots of 5.
Can you divide the square root of 20 by -2?
No, you can't. You can't divide those because one's inside a root, one's not. But you can simplify this. We know that this will become 2 and this will become 1. So it's, and the negatives cancel. So it's 2 plus or minus square root of 5. So then you just need to put it in your calculator. 2 plus square root of 5. So x equals 4.2. And then you can do 2 minus square root of 5. X equals negative 0.2, 0.2.
It's plus or minus. It can be negative 2.
So your two intercepts are decimals. So it'd be 4.20 and negative 0.20. These are your x-intercepts. So if you're asked for the exact x-intercept, you can find it using your quadratic formula. All right, let's do the y-intercept. So it's found by plugging in 0. If I plug in 0 here, what's going to happen? It's going to cancel. So f of 0 is just 1. So my y-intercept is 0, 1. So let's see what we can graph on this. We can graph our vertex. So we found that over here. It's 2, 5. 2, 5. Our y-intercept is 0, 1. And it opens downward. We know that axis symmetry goes through the vertex. So since we have the axis of symmetry, I can do this other point over here, 4, 1, because it's symmetrical. And if you remember about quadratic functions, since this doesn't have a number in front of it, like 1, 2, 3, 4, and so on, this is just down 1 over 1, down 1 over 1. And then we can kind of graph our x-intercepts. See, I said kinda. So you're kind of estimating where they'd be. So once you have them, you can do your parabola.
Why would it not be at 5
Where at?
or
Which-
negative 1 at 5 as your x-intercepts? Because you said down 1 over 1.
Here,
Mm-hmm.
those two. Yeah, only your first movement. You can do that. It's kind of like rise or run, but it's only the first point after your vertex. After that, it becomes squared. Like 2 squared is 4. So you'd actually go down 4 over 2. And then you could go down, 9 over 3? Okay, let's do our domain and range. So our domain is all real numbers, quadratic functions, all real numbers. So it's negative infinity, positive infinity. And our range, it's all the way up here, and then it goes down. So it's negative infinity up to 5. Okay, so we're going to find the minimum and maximum. So this point would have, this is called what's a maximum. It's the highest point that it can go. So if it was flipped around, then we would have the vertex as our minimum. So let's say it's like this. Then this point is a minimum. And you find the maximum or minimum by looking at the y value of your vertex. Because it's how high it goes, and the height, either high or low, is your y value. So the value of y, or f of negative b over 2a, gives the maximum or minimum value. So it's the y of your vertex. That gives you your max or min. We are going to determine without graphing whether the function has a minimum or a maximum, and then find the min or max. So if we look at our function, f of x equals 4x squared minus 16x plus 1,000. Our a value is positive, so we know it's going to open upward. So since it opens upward, we are going to have a minimum. It's our lowest point. So we need to find that minimum value by doing x equals negative b over 2a. So the x value of our vertex, and then find our y value of the vertex. So negative and then 16. So this is b, this is a, this is c. So it'd be negative 16 over 2 times a. So those cancel, and we just get 16 over 8, which equals 2. But that's not our minimum. We have to find the y value of the vertex. So we have to plug it in. So f of 2 So we can use our calculator to find that. 2 squared is 4. 4 times 4 is 16. 16 times 2 is 32. If I subtract these, what do I get? Yeah, negative 16 plus 1,000. And what's that?
984.
Right. So that is my y value. So my vertex is 2,984. So then my minimum is 984. So without actually graphing, we need to come up with our domain and range for this. It's quadratic. So it's going to continue from left to right. So our domain is negative infinity, positive infinity. So let's find our range. So for our range, what's our minimum value? 984. So where does that go in our range? First number. And then since it is our minimum, the highest, the max, is infinity. If it was a maximum, it would be reverse. You would have negative infinity to a certain number. Okay, our last problem is about maximizing or minimizing areas or different real world situations. So here are the steps to read the problem and decide whether the quantity is to be maximized or minimized. Use the conditions of the problem to express the quantity as a function in one variable. Rewrite it. Calculate negative b over 2a. And then plug it in. And then find the maximum value. So let's look at our problem here. Let's go ahead and read over the problem. So there are no parts A through C. I have to give those to you. So part A is going to be, what is the max height? So that'll be right here. So in order to find our max height, we need to find our vertex. So negative bx equals negative b over 2a. So we have A, B, and C. Negative 2.7 over 2a. So we need to put that in the calculator. The whole thing? No. Yeah, the bottom is.
The answer is negative 0.0675.
The whole thing?
Yes. No, I didn't got a problem.
Hold on.
My bad.
I thought I did this earlier and maybe not. Negative 2.7 divided by 2 times negative 0.05. Y'all ready? 27. So does 27 look right?
Yes.
Yeah. Okay, so that's good. Now we need to find the y value. So plug in 27. So whenever we plug it in, get 42.25. So that is our max height. And we are in feet. Part B is going to be a maximum distance. So thinking, because this would be 50 right here. So it's somewhere around there. So how are we going to find that? What is that called if we're doing max distance? X-intercept, yeah. So we need to do our quadratic formula. So x equals negative b, so negative 2.7 plus or minus square root of b squared, so 2.7 squared minus 4 times a times c all over 2a. So that looks like a lot of fun. So we can use our calculator and put that in. So I would do the plus and see what you get, and then do it, just change the plus to a minus and see what you get. And you'll get the two different answers, and you'll see which one is our positive answer, because that would be the correct answer. The negative, there's not a negative distance. We're looking for it's close to 50 something, 50 to 60 range. What was it? You just made it up? Okay. Close. I think I did my calculator.
Don't worry, we got mathematician later.
What'd you get? Negative what?
Negative 0.04.
No, I got negative 2.0688. Mm-hmm.
What's the max
So
distance?
that one is the negative number, so that one's not right. So I need to go up and change this. So this would be minus 56.07 feet. Yeah, you were really close. Okay, so that's our max distance. Our last one is, what height was it released at?
0. No. It's a y-intercept. I guess it depends on how tall the person is, where their hands located.
Not solid 5.
5.13.
Look at your equation.
5.8.
There we go. Good job. 5.8 feet.
So how tall is the person? Pretty short.
They would be, oh yeah, it'd be right here, right at your shoulder. But released would be right here, right?
Yeah.
Is that whenever you release it?
Yes, so they are.
They are short. Okay, short.
Maybe it's junior high kid. All right. Where's your assignment?